Hello, everybody. We're going to continue our exploration of electron configuration. Remember what it's all about? She's saying P block and S block. I have to wholeheartedly agree because the number one tool for doing this is your periodic table, right? So quick little review. We've got our last page here that has our periodic table on it. And where's the S block? The first two. I'm trying to get my pen going here. There we go. Highlighter. S block in pink is right there. S block. Need a pink pen for that, of course. S block. And if you're following in order, then you're not getting to the middle area. You're going to encounter some elements that have, thank you, this area here. And what area is that? The P block. Let's give that a little blue action. And we want our pen as big as possible. Yeah, we're in the P block here. Nice. That means your last electrons are going to go in what kind of orbital? P. What does it mean when you're in the S block? Your last electrons. I almost said by accident the word valence, but some of you know that's appropriate because the last electron that goes into an atom is a valence electron. Valence electrons are the electrons of chemistry, the ones we can manipulate to get things to happen the way we want. So what's the middle area? Again, D block. Get some yellow. I remember a day when yellow highlighters were the only highlighter available. Yeah. Some of you are saying, what's a highlighter? Okay. All good. I don't think the yellow works very well. Maybe if I have a big wide yellow. What do you think? D, that's a little D. D block. Does that show up okay? Yeah, good enough. So let's try to use this as we go and do our first activity today. I think the fastest way is just go 1, 2, 3, 4. Getting a preview. Supposed to give the complete electron configurations for the following and circle the valence electrons. We don't know how to do that yet. We'll know when we get there because we'll talk about it. So let's go to the end and look for nitrogen. First question, which block is nitrogen in? It's in the P block, means the last electrons you're going to put in there will be in the P level. What number is going to go in front of the P level? 3, she said. I have to disagree on that one. Yeah. Once you get to the second row, nitrogen's in that. That means its last electrons will be second level. Means its valence level, here it is. The valence level electrons are any electrons in an orbital that has a 2 in front. Either 2s or 2p and or. Okay, if it's got 2s electrons and it's got 2p electrons, those are all, the whole set of them is called the valence electrons. We good? And we're not good. Well, maybe this will help. Where do the first 2 electrons go in any atom that's beyond atom number 2? 1s, yes. Yeah, so it's the smallest s orbital gets 2 electrons and then it's full. What element did you just finish when you said that? There's only one element that has only 2 electrons in the 1s orbital. Helium. Hydrogen has one electron in its s orbital, and helium has the second electron in the same s orbital. Okay. For that reason, helium could go over here. It would fit nice over there. So why is it way over here? Well, it belongs with the noble gases because its behavior is the same as all of them. Okay. And then where is the first electron in lithium going to go? The third electron. I know where the first two are going. They're going in the 1s orbital. That's where they always go. First two electrons for lithium, 1s orbital. Gets a 2 above, right? And then you have to put the third electron in, which will be the last electron. And where does it go? Don't say 1s. 2s. It says 2, and you're in the s block. The periodic table gives you the answer. What is the last orbital for a lithium? Well, it's in the s block, so it's an s orbital. It's in the second row, so it's a 2s orbital. End of story. And now you've got 2s2, and you're at beryllium. You're not to nitrogen yet. Isn't that our goal, to get to nitrogen? I forgot already. Then you're going to put an electron in what orbital for your fifth electron? The 2p. And then the sixth also goes into 2p. And the seventh also goes into 2p. You go 2p until you finish this row. But when you're in nitrogen, you don't get finished the row. It's right there. It's halfway. So it's going to be 3 in the 2p orbital. Let's write that down like it's important. And we're going to go to the fourth last one. I think it's the one previous to this. Yeah. Sorry. Jumping around a bit. This is activity 1. As you have this one in front of you, I hope. Tell me where the first 2 electrons went. 1s. What a big. And there's 2 electrons in there. Where are the next 2 electrons? Well, periodic table tells you. I know you can't see this in the video, but 1s got me, 1s2 got me to helium. And now I'm going to 2s. That's what's next on the periodic table. Don't say 2s2. That's too many electrons. Oh, yeah, it is. I thought I was doing lithium. 2s2 is perfect. I apologize. I'm stuck on lithium. Now you're past lithium. You're at beryllium, aren't you? 4 electrons in black here. 4. That's element 4. Beryllium. 5. Where's the next electron go if you were boron? 2p? It's 2. Oh, note to self. Note to self, the number in front of S and the number in front of P in a row always match. Okay? So if you wrote 2S in the second row, you better have 2P right after that. Okay? All right, and we've got to get to what number? 3, because I'm only at boron, then carbon would have 2, and then nitrogen has 3, and you're done in this class. We don't have to go further than this. Let's put a black 3. Be consistent here. That's it for this class. That's it. And we're not going to make you do the boxes with the arrows in them. Okay? 141, you get to do that. It's just the same as this, except there's a little more information. You're showing me that you have to singly occupy the P's before you start doubling them. Do you remember that? You kind of forget it in this part. Okay? But I think Pearson's going to make you remember it. Yeah. So when you're putting them in the p orbitals, you put one in one of the p orbitals called the px orbital first, because we like x, y, z, right? And what does px mean? I'm just going to show you. This is not part of your activity. You don't have to copy it down. This orbital here, that's a picture, and I'm a terrible artist. I think you already know that. Okay. And because it's along this axis here, it's called what? Px. We didn't know. All right. Now there's an orbital that's 90 degrees perpendicular to that. You guys know the word perpendicular? It means 90 degrees. Those orbitals are supposed to look the same. They don't. Yeah, I don't know. I can get a little thicker here. Could have copy pasted and rotated 90 degrees. Okay. Bear with me. What are you going to call that one? Py. And how do you do a pz? That's tricky. Yeah, I'm trying to show you the z-axis with the dot coming out. It's 3D going out and in, right? The z-axis, the x and y are here in this plane. The z is this plane coming at you. Okay, and so that's pz. And if I had to draw it, I don't know, maybe I'll try to make it like it look big and chunky out here, and it's kind of fading into the background there. All the orbitals are supposed to look the same. You got to have a good imagination in this class. And they're 90 degrees from each other, and they don't touch each other. That's the important thing. Remember, you're going to put an electron in there. I put it in the px orbital. There's an electron. Electron right in there. Where's the next one go? Does it go in the px where there's already an electron that this thing hates? Or does it go to an unfilled orbital that's got room to roam without encountering any electrons? I gave you the answer. Next electron goes there. So really, there's a dot here in this orbital. That's an electron. And there's a dot here. There's not two dots in the x or two dots in the y or two dots in the z. There's one in x and one in y. And like I said earlier, it could be one in y, one in z. The atom doesn't know the alphabet, right? You need to know that? No. And we're talking nitrogen. There's one more electron to go, right? Maybe I'll make it in blue so you don't mix it up with all the scribbles in black over there. There it is. Okay. So really it's PX1, PY1, PZ1, right? And this is Chem 141. I just want to be real clear. That's when you know about that. Moving on to the next example. K. You've got your periodic table. Let's just read it across. Where do the first two electrons go every time? 1s2. I'm going to go monochrome now. Next two every time. 2s2 gets you to beryllium, doesn't it? Hey, if you do this, you never have to count how many electrons you've counted already. If you just use the periodic table. You don't have to keep track. Oh, I'm at electron number 46. So I got to get to 47. Oh, I'm never going to do that. I'm going to keep going until I get to potassium and I'm done. So where are you now? Remind me. After you said 2s2, where are you here? Give me an element, please. Beryllium, Be. Now you've got to get boron, carbon, nitrogen, oxygen, fluorine, neon covered with the next 6 electrons. How do you do that? So say it again. 2p6. Remember, each p orbital can hold 2 electrons, and there are 3 of those orbitals. So 6 electrons get you to the end of the p block. You can't forget there's 6 in the p block. It's right there. You can't forget there's 10 in the d block, 10 in the d block. It's right there. You count across in the d block. You can't forget there's 2 in the s block. There's only 2 columns in the s block. All right, so what's next after 2p6? Follow it. 3s2 gets you to what element? Magnesiums. You're not done. You didn't say potassium. You're not done. Okay. What's after that? Just follow the periodic table. What block are you in with element 13 now? 3p6, because S and P always match. You are now at what element? Argon, about to get to potassium. I'm not there yet. If you put 3p7, you can't do that. No, there's not room for 7. No. You're up to the end of the third row, which is argon, and potassium's next. You only need one more electron. Where does it go? 4 in the S block, 4s1, which you said about 8 times. And it was right every time. Okay. Okay. She knew the answer. Okay. Where are we going next? Well, we got potassium covered. Notice I didn't count how many electrons there were even, did I? I do happen to know there's 19 listed here because it's element 19. 2, 4, 10, 12. Well, the 6 and the 4 are a little confusing. One's for the 4s orbital, right? I want it to be clear that that has nothing. It's not a 3p64. We're not doing that. That's a 4s1. 4, big old 4. Good. And that gets you to potassium bismuth. Bismuth, where are you? Son of a bismuth, I remember. They made us memorize the periodic table, so you have to have memory tricks, right? And a good chemist. Hey, do you want to have some memory tricks on video? They're fun, and you don't have to know any of them, so it wastes a lot of your time. Oh, go, Dr. Whitaker, do it. Okay. It doesn't waste your time. I'm going to my periodic table. And remember, a chemist always thinks in columns. Why? Why does a chemist always think in columns on the periodic table? That behavior goes by columns. Okay? The chemistry, which you don't know anything about yet, you've got a glimpse of chemistry for the first time in lab this week. It's great. It's mixing stuff. So what we're doing is Dr. Whitaker had to memorize these things, and he came up with some memory tricks that only work for him. And that's the way you come up with memory tricks. The best ones are the old ones that work just for you, because you've used your personal life experience to come up with them. You can read about them, about magnificent kings and things like that, which is a really good one, by the way. Several students had that one written for, well, for what? Something about magnificent kings. Anybody? What were they? They found a trick online. I encourage it highly. Guys, I know like 4 people in this room had this written on their exam. They're not talking to me right now. I'm sad. That means they're not listening. What did they had? The mega had one of the words starting with an M. Giga had another word. And I even added one of the words at the end. That's the guy in the back corner. I'm going to put him on the spot because he's not even watching. Yeah, I put it on your exam. I commented to you after I gave you your exam back. I figured out a good one for the last P. You don't remember? Man, that wasn't you. It was the guy behind you. He's getting his test out now. He's going to read his, read the whole thing. Read all the words. You got them all, don't you? The great mighty king drinks chocolate milk Monday night. And I had and peas. Because you drink all that chocolate milk, you got to pee. And there's your pico at the end. There's mega and giga in there. It's just memory tricks, okay? And you guys need to know, though, that doesn't go away. You said, oh, that's only on test 1. I got news for you. I don't want it to be bad news. When you have to convert mega to milli unannounced on test 2, this is the only announcement. You're going to say, you didn't say that was going to be on the test. Video, October 12th. Did I get that right? 11. Hey, I got to get this right. Video October 11, I said you're going to have to do all the prefixes every test ever in chemistry. Okay? You have to know them. They're that fundamental. That's how we talk. It's like you're refusing to learn the language if you refuse to learn them. Yes, chemistry is its own language. Okay. So where was I? I was going, memory tricks. Sometimes I just like sounds because my brain works with sound. That's a rare learning style. I understand that. So I've had to learn about other learning styles, but right now it's mine because this one was just Kasserbara. Doesn't that just sound nice? Kasserbara. I had the first bunch just learned from using over and over. So a lot of the times I'll skip the stuff at the top. Skylark sounds like an old car and a song, a jazz song called Skylark. So I got that. I don't have much for this except I made up a word, Tizerhoff. It's just a word that works for me. My favorites from a fellow graduate student. This is group 6. You see that? And we're in Detroit. You're going to love it. 6 crazy Motown women. Nothing? I didn't even get a chuckle? Okay. How about feeble runts are ostracized? Yeah, that's a little mad. What about it? Sometimes it's just like, these are all money to me, copper, silver, gold. So I remember those together, they're money. And these are all batteries, but you have to know a little chemistry to know that. But then you get some more fun stuff. Beware, Alf gags in toilet. Back in my day, there was a TV show called Alf, was a puppet alien. Do you even know it? She knows Alf? It was from the 80s, I think. Okay. And anything else? Arsenic is a son of a bismuth to remember. You like that? Okay. This is letters that kind of go together to me. I don't know why. Halogens I knew from 100 years ago, so I didn't have to have anything. And noble gases, most chemists just know them. But, you don't have to do this. I saved the best for last. The memory device for one person in this world to get me all the way through the second last row up to uranium. You ready for it? It's totally nonsense. You ready? I'm going to go one at a time. I have an uncle named Cyril, so that's where we're starting. Sorry. Cyril, protect North Dakota, promise Samaritan Europe, good trouble, die, hold tummy, YB, Lucifer, pay you. You like that? Lucifer has to have a lift because it's a th. See that? Lucifer, pay you. Then it's a bunch of planets and people, so that helps with, if you got some reference points there. Oh, and the new elements. We didn't have to do any of these down here because they didn't even exist when I had that course where I had to do this. You want my new trick? Rough-a-dub sub be his motto. Dastardly Renkin cannot annihilate Flomax loving Tennessee orgy. What? He said orgy in class. Oops. Okay. So my teacher's insane. Okay. So what were we doing anyway? I don't even know. We were here for a reason. Electron configuration of what element now? What's your second one? Bi? Bismuth. Yeah, we got a lot of work to do. Woof. Bismuth's nasty. Yeah. So where do you even start? It's always the same. 1s2. Yeah, I like it. You're programmed yourself. And we're going back to starboard. I'm in starboard. I got to go back 4 times. Bismuth. Son of a bismuth. Where are you? Ignoring me. Did I go too far? Documents. We're working on this one right here. Hello? I guess we're not. You just decided to go slow. Okay. 1s2, 2s2, 2p6, 3s2, 3p6. Oh man, you're good. Oh wow. I wanted to save time and it's not working. So I was going to copy paste everything I did from the previous one. Being mean to me now. It's everything above, except you're going to fill that 4s, aren't you? You just got to the one past potassium. What's that? Calcium. Now, what did I tell you about the D level? There's only one thing that you have to know, and I'm going to tell you again. The number that goes in front of D is always one less than the number in front of the S that you just did. I just did 4s. What's the number in front of D? 3D10. What element did you just get to? Not quite. Careful. We got to zinc, end of the D block. We did not get into the P block. All right. So we got to fill what row? Remember what I said about P versus S? What was the last S you used? What number was in front? 4. It must be the number in front of P now. 4P. And you have to get past this row, past the 4th row. How many go there to get all the way to the end of the P block? How do you remember that? There's 6 across. What's after 4p6? You're at argon. No, you're at krypton. Now we got to get to rubidium. We're not even in the bismuth row yet, so don't worry about half filling anything. What do you write down next? 5s2. What's after 5s2? Remember what you say about D block? 4d10. Quick study. What element are you at now? CD. You finished with CD. You got to get all the way to XE. Sorry, now XE. Remember, the P matches the previous S, and you have to fill it. Miss Snowden, you need to answer that question on your own because they always start exactly the same. Okay, sorry I used your name. Did I get it right though? I think I used your last name on a video. I have to ask for your permission now. You asked a question, and it was a good question. She wanted to know if that was a K or an S there. And I was just reminding her, every time you start one of these, it's at the same every time. The first orbital you fill has to be 1s. That's just the way the atoms are. The simplest, closest to the nucleus is first. It's number 1. All right, so what's after 5p6? You're at the end of the 5th row now, xenon. 6s2 gets you to barium. 6s2. My writing's not clear all of a sudden. I thought we had these problems solved. We did. My hand was on the screen somewhere else. 6s2. You are currently at barium, and you got to get past mercury. So what gets you to mercury? 5d10. And now you're finally, are you in the bismuth row? No, we're not. We got to finish the 5th. Where am I? Yeah, I'm in the sixth row. Sorry, the 5 threw me off. This learning's hard. Currently, I am past this, right? And that was 6s2. And then I got to Hg with 5d10. And now I've got to get how far past Hg? How many? 1, 2, 3. So 6p. Why 6p and not 5p? The next p always matches the previous s. Just remember it that way. What's your previous s? I just wrote it, 6s. So your p has to match that. 6p3. Nobody likes it. That's why we're going so slow. You are not alone. And I haven't done this part yet. Yeah. Yeah. What am I doing? Yeah, sometimes I'm circling more than one type, and sometimes I'm circling just one type. Wait, that wasn't right at all. I thought it was at the end there. I was not. This is the end of this molecule. So what did I circle every time? I didn't do that in the potassium example, part B. She said I did the S block and P block every time. I have to disagree. Sometimes it's S block, sometimes it's S and P. How do I decide what to circle? The orbitals with the highest numbers in front are called the valence level orbitals. Every electron in the valence level orbitals is called a valence electron. That's what I did. Why did I circle the 2s2 and the 2p3? Because those have the 2 in front of the name of the orbital, which means they're the highest energy level in this atom. The 2, that's what the 2 means, in front. What's the highest energy in front of any orbital here? Give me a number. 4. Only pick electrons at the 4th energy level. What's the highest number for bismuth in front of any orbital? 6. Only the 6th level electrons are valence electrons. Now, I'm going to add a question just to do it real quick. C. Lewis structures. Lewis structures. Lewis dot structures. Once again, a gentleman has his name on things. And I got to be fair to Mr. Lewis. He didn't do this. Is there a part C? I'm doing, see, this is the problem with using the same kind of questioning and answer. I had A here and here, which caused confusion, clearly. So we'll make these Roman numerals I, and I, and I. Okay, so we did 2, and we should put that in red. There we go. And I'm just going to do Lewis dot structures based on what I'm looking at the top of the screen. And you tell me, somebody take a stab why I'm doing this. Or I'm just going to do 2. What do they have in common? How many dots on each one? 5. Why 5? 5 valence electrons. Why are 2 of them paired? Why are these 2 paired and the other singles? And that has to do with what I did down here. In the p orbitals, remember, do you double them up first or do you single them up and then double them up? Single them first because electrons hate each other. If they have a choice of going where there's no electron or where there is an electron and it's the same type of orbital, they're going to go where there's room for where there's no electrons. So you're showing 2 of the electrons are paired. They're called the 2s. I will remind you, those are the 2s. And these are the px1, the py1, and the pz1. And I don't have to point to the other one, do I? There you go. And I'm going to do bismuth right now for a reason that should be clear after I'm done. I'll just do one version of bismuth. Why did he go right to bismuth? And why is this computer not writing? I'm having a hard time. Bottom of screen might be a bad area to do business. Why did I choose to do bismuth next? It also has 5 valence electrons. You see them? I circled 5. 2 of them are in s orbital. 3 of them are in p's. This is why the chemistry of nitrogen and bismuth is so similar. This is why. Because their electron arrangements are the same at the valence level. That's the level of chemistry. Yes, sir. I think my question answers your question. I gave 2 examples that would get full credit here. He was asking, does it matter where you put the 2 and the 1 and the 1 and the 1? No, and there's 3 other options that you could do. No, 2 others, where the lone pair, or the pair goes on top, pair goes on the bottom. There's your other 2 options. Yeah, it's atoms don't know directions. So careful that dot there is for the letter I. Yeah. Okay. I'm going to put potassium here. It's an easy one. How many electrons are on potassium? 1. Done. 1 and done. That's it. I think that's it for the activity, or is there another part? We did circles for B. Yeah. Want to do a trade? Stop the share, stop the video.